Hello, welcome to video 1D. This video is about points of intersection. I'm Mr. Miller and I hope you're having a great day. We see kind of a picture here of what we're trying to do. In this graph we have a parabola and a line that intersects it in 2 points. Our job is to find the coordinates of the points where they intersect. We're going to do 4 problems. 2 problems with lines and 2 problems where one's a line and one's a parabola or a circle. Alright, let's go ahead and do it. Okay, so this is kind of intense algebra here. Alright, so we have 2 equations. Our goal is to find all ordered pairs x and y that satisfy them. And we're going to use the method of substitution. Sometimes elimination, where you kind of add the equations, is faster when they're lines. But when they're not lines, we have to do substitution. So that's why I'm practicing it. So we got to take one of the variables and solve it, or one of the equations and solve it for a variable. I see this x here looks really easy to solve for. In fact, if I subtract 2y from both sides, I get x equals 1 minus 2y. So remember, we can kind of move a term across the equal sign if we switch its sign. If I subtract 2y from both sides, it's going to cancel here, and over here I have 1 minus 2y. That's where that came from. So now I can take that and substitute that in for x in this equation. So I'd have 5, I need parentheses because x equals the quantity, 1 minus 2y. So it's 5 times all of that, minus 4y equals negative 23. If you want to use your graphing calculator to solve this, you could enter this equation and have it solve it for you. You can do that all along as we're doing these problems. Let's go ahead and try to do it by hand. So 5 times 1 is 5. And we have minus 10y minus 4y equals negative 23. So I have 5 minus 14y equals negative 23. Subtract 5 from both sides. We got negative 14y is negative 28. If I divide by negative 14, I get y equals 2. I have one of the coordinates. So what I do is I go back to the equation I used for substitution and I put 2 in for y. And it'll tell me what x is. So x equals 1 minus 2 times 2. So that's negative 3. And so the point they cross is at negative 3, 2. This is actually a graph. There's not a grid on it. The blue line is the first equation. The red line is the second equation. And we see that intersecting at negative 3, 2. Looks like that's pretty likely. Okay. Next. Let's try another one of these. So again, we want to pick a variable to solve for. Alright, so I'm just looking. I kind of like this y right here. Or actually, I like this one. So if I move it to the other side, it becomes positive. So I get 2x plus 2 equals y. So if you haven't seen that kind of before, all I did is I added y to both sides. It disappears over here, becomes plus y over here. Alright, I'm going to take that and substitute into this other equation. So I get 4x plus the quantity 2x plus 2 minus 5 equals 0. There's really nothing to distribute, so I can combine like terms. 6x plus 2 minus 5 equals 0. That's negative 3. So when I add to both sides, I get 6x equals positive 3, or x is 1/2. Alright, go back to this equation. And I get y equals 2 times x, which is 1/2, plus 2, that's 1 plus 2 is 3. Okay, that's the coordinates of the point. We get x equals 1/2, y equals 3. And again, blue line's the top equation, the red line's the graph of the second equation, and that's where they meet. That point must be 1/2 comma 3. Alright, now, things are going to get a little more interesting here. Because one of the equations is quadratic. The first equation is a line. This time that's the red graph. And the second equation, that's the upside down parabola. Alright, so we can see from the graph that there are going to be 2 points of intersection. Alright, so we're going to expect to get 2 values of x when we solve this. So we're going to do substitution again. If I notice, it's going to be easiest to plug in for y. So I'm going to solve this for y. After a while, you get a little instinct for this. So I subtracted x from both sides. I'm going to substitute 2 minus x in for y. And see, when I do that, I don't have to square anything. equals 2 minus x, or sorry, plus 2 minus x equals 8. I'm going to put this in standard form. We got x squared, we have minus x, plus 2. I'm going to subtract 8 from both sides. It's going to be minus 6 equals 0. Again, now we have a quadratic we're solving. If it was really messy, you could use the graphing calculator. But this one's not bad to factor. I get x minus 3 times x plus 2 equals 0. And we're going to use ZPP. If I do that, x equals 3. If I put in 3, 3 minus 3 is 0. 0 times anything is 0. Or x equals negative 2. Now I got my two values of x. I have to go back and plug them in to get my two values of y. So when x is 3, I'm going to put 3 in here. 2 minus 3 is negative 1. And when x is equal to negative 2, I'm going to put negative 2 in here. 2 minus a negative 2 is 4. Okay, so again, I had to go back to the equation I used for substitution. I had to go back there twice, but these are the 2 points of intersection. All right, we got one more. So this one, let's see how this goes. We have a circle. X squared plus y squared equals 25 is an equation for a circle centered at the origin with radius 5. I don't know if you remember that from an ACT prep or not, the equation of a circle. And we have a line that crosses it, and again, it intersects it at 2 points, so we're expecting 2 solutions. Okay, this is the easiest thing to solve for. So I get y equals 10 minus 2x, and I'm going to take that, put that into here. So we have x squared plus quantity 10 minus 2x squared equals 25. If this calculator is allowed, I'd be on this already, having my calculator solve it. But here we go. I'm going to show you how to do it by hand. So we have x squared plus, when we square this, we got to FOIL this out. So it's 100. It's going to be minus 20x, and another minus 20x is minus 40x, plus 4x squared equals 25. All right, well, 4x squared and x squared is 5x squared. We have a minus 40x. I'm putting it in standard form. 100 minus 25 would be, if I move that over, would be plus 75 equals 0. Let me see, divide everything by 5. I have x squared minus 8x plus 15 equals 0. Whoops. Okay, I lost it there just for a second. Sorry about that. So we're solving this. X squared minus 8x plus 15 equals 0. All right. We've gone a long way. Unfortunately, this one's easy to factor. I need two numbers that multiply to 15 and add to negative 8. That would be negative 3 and negative 5. So this factors as x minus 3 times x minus 5 equals 0. And x equals 3, comma, or x equals 5. Okay, so first point, 3. When x is 3, go back to this equation we use. 10 minus 2 times 3 is 10 minus 6, which is 4. That's our first solution. All right, put in 5. 10 minus 2 times 5 is 10 minus 10, which is 0. Those are our 2 points. All right, now, so this method of substitution is pretty general and powerful. Try to solve one equation, use the linear equation for y, or x, for whatever variables by itself, and substitute it into the other. You get a nasty quadratic equation. Things like this are going to happen all the time in calc, and it may be rough at first, but as you practice and do more and more problems, it gets quicker and quicker. All right, time for a journal assignment. So the first one, these are 2 lines, so you should get 1 solution. I would solve for that x right there is probably what I would do, and whatever I get, substitute into the first equation. The second one here is a parabola and a line. You can set these y's equal to each other, which is the same as taking this 2x plus 1 and substituting it in for y. So you get 2x plus 1 equals x squared plus 4x minus 7. Put it in standard form, try to factor it, or use the quadratic formula, and you should probably get 2 values of x. All right, good luck with that.